Coefficient of volume expansion. Coefficient of volume expansion of solid. Coefficient of volume expansion of solid. In the diagram, a cubical body is shown. L1 be the length of each side of the cubical body. L1 be the length of each side of the cube at the initial temperature T1 degree C. And initial volume of the cube is V1, which is L1 cube at the temperature T1 degree C. Now the temperature is increased to T2 degree C. Length of each side increases to L2. L2 be the final length of the each side of the cube. Final volume of the cube becomes V2, which is L2 L to the power cube. V2 is equal to L to the power cube, which is the final volume of the cube at the final temperature T2 degree C. Let V1 be the volume of a cubical body. V1 be the volume of a solid cubical body with each side of length L1 at the initial temperature T1 degree C such that V1 will be equal to L1 to the power 3 or L1 cube. V1 is equal to L1 cube. V1 is equal to L1 cube, which is the initial volume or volume of the cubical body. Volume of the cube or volume of the cubical solid body at the initial temperature T1 degree C. At the initial temperature T1 degree C. Similarly, V2 be the volume of the same cubical body with each side of length L2 at the final temperature T2 degree C such that V2 is equal to L to the power 3. V2 is equal to L2 cube. V2 is equal to L to the power 3, that is the volume of the cubical body. Final volume of the cubical body at the final temperature T2 degree C. Now change in volume of the cube, that is V2 minus V1. Change in volume of the cube, that is V2 minus V1, is directly proportional to V1. Also V2 minus V1 is directly proportional to T2 minus T1, where T2 minus T1 is the change in temperature of the solid body. Simultaneously, you can write V2 minus V1 proportional to V1 under bracket T2 minus T1, bracket closed. V2 proportional to V1 T2 minus T1. Therefore, V2 minus V1 is equal to gamma V1 T2 minus T1. Gamma V1 T2 minus T1. That is the change in volume of the cube due to change in temperature by T2 minus T1 degree C. V2 minus V1 is equal to gamma V1 T2 minus T1, which is the change in volume of the cube or cubical body due to change in temperature by T2 minus T1 degree Celsius. Therefore, gamma is equal to V2 minus V1 divided by V1 into T2 minus T1. Gamma is equal to V2 minus V1 divided by V1 T2 minus T1, which is the coefficient of volume expansion of the solid body. Gamma is equal to V2 minus V1 divided by V1 into T2 minus T1, which is the coefficient of volume expansion of the solid body. So, coefficient of volume expansion if T2 minus T1 is equal to 1 degree C or 1 Kelvin, that is change in temperature is 1 Kelvin, and initial volume V1 is equal 1, then gamma is equal to V2 minus V1 divided by 1 into 1. Therefore, gamma is equal to V2 minus V1 only. That is, coefficient of volume expansion is numerically equal to change in volume of the cubical body. So now we can write down the definition. Therefore, the coefficient of volume expansion of the solid body, volume expansion of a solid body is defined as the change in volume of the body, as the change in volume of the body is defined as the change in volume of the body The coefficient of volume expansion of solid body is defined as the change in volume of the body for unit change in temperature. For a unit volume of the body. So the definition will be again, the coefficient of volume expansion of a solid body is defined as the change in volume of the same body for unit change in temperature for a unit volume of the body. Now V be the initial volume of the body at initial temperature T degree C. Temperature is increased to T plus dt degree C. Assuming change in temperature is very small, final volume becomes V plus dV. Therefore, coefficient of volume expansion of the body is gamma, which is 1 by V into dV by dt. Gamma is equal to 1 by V into dV by dt, which is the coefficient of volume expansion. Coefficient of volume expansion of the solid body. Gamma is equal to 1 by V dV by dt, where dV be the small change in volume of the body, dV be the very small change in volume of the body due to small change in temperature. dV be the very small change in volume of the cubical body due to change in temperature by dt degree C or dt Kelvin.